Okay, guys, let me go ahead and do a few of the problems with y'all for your assignment, just kind of preemptively. Let's see, did I share that right? Okay, so again, this is a random number generator, so yours are not going to always be the exact same as mine. I'm not going to do all of the problems. I'm just going to do a few of them. Wait, where did my annotation go? Hold on. There it is. Okay, sorry guys, technical problems. All right, I got it. All right, I'm not going to do all the first few ones. Those you just plug in because they're continuous. Model 1. So first thing you try is just plugging in the number. And if you get a number, you're done. So negative 24 plus 3 gives us negative 21. So we're like, hooray, we did it right. That's the same for number 2. So let's scroll down. Same for number 3, number 4, all of those you just plug in. Number 5, plug in, you'll get a fraction as your answer, that's okay. Number 6 is limit properties. So don't be scared by that notation. You're just gonna plug in. So this says x goes to 3 for f of x. So you're gonna plug in 3 for that x and that x. So 2 times 3 squared minus 3 times 3 plus 14. So 2 times 9 minus 9 plus 14. So that's 18 minus 9 would be 9 plus 14 would be 23. And you're going to do similar for the other ones as well. This one, when it says g of f of x, plug 3 into f, like we just did. And a, so that was 23. And then you're going to plug 23 into g, which is what you just did in part B. So this is going to end up giving you the same answer as B. Let's see, you got trig. Again, that's practice unit circle. See if you can figure out the unit circle. Go through, review, look at that trig video I posted. We're at pi. If you're counting around, this is 0, this is pi over 2, this is pi. The x value is -1, y is 0. Tangent is y over x. So that would be 0 over -1. So tangent is 0 there. Here you're gonna plug 6 in. So 6 pi over 3, that's the same as 2 pi. What is the cosine value over here at 2 pi? Because you can go around the circle many times. This would be also 4 pi, etc. So the cosine value is the x value, which is 1. All right, you're gonna plug in there e to the 0. I also have a review video over e to the x and natural log. You need to know e to the 0 is 1. And cosine of 0 is also 1. So this one would just be 1. Let's see. 13 pi over 4. Where would 13 pi over 4 be? If I plug in 13, let's count around the circle. You could literally just count out pi over 4, 2 pi over 4, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9, 10, 11, 12, 13, we'd be here, okay? Or you can think through it a little bit more with some division. And we're finding the tangent here. And so the cool things about the pi over 4s is that the x and y coordinates are the same. And so the tangent is either going to be 1 or -1, depending on what quadrant you're in. We're in quadrant 3, so the tangent is 1 because they both are negative. And a negative over a negative is a positive. 11, you just plug in 1. Hold on, babe. You just plug in 1, you get 1 over e to the 6, that's okay. Number 12, you're going to plug in these values too. So this is actually a really simple section. Don't overthink it. Hold on, baby. I'm gonna help you in just a minute. I'll help you in just a minute. 4 times f of x, the limit is 6, so this is gonna be 24. This is just f plus g, so you just add these up. That's f times g, so you just multiply them. That's f over g, so you divide them, which is the same as multiplying by the reciprocal. Now, this one, when we plug in -6, It's finally one where we get 0/0, which is, oh, more work to do. Remember the trick. This tells you you're trying to get rid of x minus -6 or x plus 6. So why a simpler function that agrees with the given function? That means factor this. So that top is x minus 6 times x plus 6. With this limit, then I could plug in -6 here. And then I could, oh wait, sorry, I wrote that wrong. Ethan, stop it. I'm just trying to. Sorry, I didn't mean write x plus 6. It's the part that's left over, which was x minus 6. And then your answer would be, if you're evaluating the limit, you would plug in -6. So -6 minus 6 is -12. Number 14 is very similar to an example one we did in class. I'm going to see if you can do that. My hint is that you're going to factor this using a difference of squares. It's very, very similar to the problem that I modeled for you in the lecture. This one, remember 8 is the factor you're trying to get rid of. So just go ahead and write x minus 8 and top and bottom, and then figure out the other one. Well, if I have 8 here, what multiplies to be 72? 9. So this would be plus 9. And then this is going to be, to give you the 64, this would be plus 8. And then you're going to plug in 8. So 8 plus 9 over 8 plus 8. So 17 over 16. And then this one you multiply by the conjugate, which again, I modeled for you in the lecture. It's that square root. So it's going to be the square root of x plus 3. You write the same thing, but then you change that sign on top and on bottom. Then on top, you always get that thing squared, which is going to be x plus 3, minus this thing squared, which is 36. And the bottom, you just write the things side by side. It looks weird, but that's okay. Then the key is to simplify the top. So add like terms, combine like terms. So now we get to see, I get to cross that x minus 33 out. So then that's the factor we're trying to get rid of. Now you can plug in 33. So we have 1 over the square root of 36 plus 6 over 1 over 6 plus 6. So my answer would be 112. That one's finding a common denominator. This one is just the number you see, because remember the sine x over x is 1, that limit as x goes to 0. Sine x over x is 1. Hold on, Ethan. So this one is 1/5. It's that number that you see there. This one is a little harder. Let's see, cosine of 0. Cosine of 0 is 1. So this is 1. Tangent of 0 is 0. So we have 0 over 0 here. So the trick with this one is to know that tan x over x is also going to go to 1, just like sine x. Because you can write tangent as sine over cosine. But let's go ahead and figure this out. So sine of 5 theta over cosine of 5 theta. And then we have cosine of 5 theta here. So I just made a substitution. Again, if you do not remember trig at all, you need to go back and review those identities, because you do need to know them for this unit. So I see I replaced tangent with sine over cosine, because that's what tangent is. You simplify. You still have this theta in the bottom right here. So now I'm left with sine theta, sine of 5 theta over theta. In order to use this identity, I need these guys to match. So I want this to also have a 5. I can't just put a random 5. So you're gonna put 5 on top as well. So this would go to 1. And so you're left with 5 times 1, which is 5. This one, if you see something where you have a GCF, factor it, see what happens. So I see they both have a 10. So I'm going to take the 10 out. 1 minus 1 cosine x over 5. Actually, I forgot, plug in the thing first. Plug in 0. If I plug in 0, I actually get 10 minus 10 times the cosine of 0 over 5. The cosine of 0 is 1, and so I get 0 over 5, which that's okay. That's just 0. This one is going to be 5/4. Is that fraction you see? That one you just plug in, 26 plus 1 is 27. And then the last one you're gonna, let's see, if you plug in 3, what do you get? Square root of 4 over 2. 2 over 2 is 1. You just, so just make sure, hold on, bud. So make sure you just plug in first, okay? Let me know if you have other questions. If that wasn't enough help, please send me a question about a specific assignment that you have or post on the homework board.